drawings, and I also do apologetics, but I realized that there was no apologetics that was really just aimed towards moms. And it's a long story, but just the way that moms have a lot less time, and they don't want to just have like a bunch of information dumped into a box. They want to see how this interacts with the real world. So we have some of these on sale if you want to come home with a present for your mom. I'm going to plug Mama Bear Apologetics. A lot of the stuff that we're going to be talking about in this is going to be in chapter 6 of the Mama Bear book, which is the naturalism chapter. Subtitle of my brain is trustworthy, according to my brain. The first time I gave this talk was for Ratio Christi TV. That's a ministry some of you may have heard about, but the original title was supposed to be Where Did Darwin Go Wrong? And I kind of thought that was a little bit of a disrespectful title, just because I was like, we can't look at what someone got wrong until we look at what someone got right. So there's going to be a lot of science talks. I will have some details in this science talk, but my goal in this talk is to teach you how to think through things before you get to college. Because a lot of the things that, what I've noticed as being a science teacher, I've taught everything. I had to fill in for a middle school teacher at one point. That was interesting. But I taught AP chemistry and biology. And then I've also gone to grad school, obviously, for biology. And what I've noticed is they kind of give you the same information the whole way along, but they just keep filling in more and more details. And the more details that they fill in, the more you're like, nah, there's no way this happened on its own. So first off, we're going to go into, I'm going to give you kind of today's outline. Excuse me. Number one, we're going to be defining terms. What do we mean by Darwinism? And secondly, what do we mean by discernment? In fact, chapter 3 in this book is solely on what do we mean by discernment, because I think we have a really whack definition of discernment. A lot of times people think to be discerning means that you just point out everything wrong that's in something. And that I call being the stench of Christ instead of the aroma of Christ. It's like, that's the stench of self-righteousness. We don't want that to be our definition of discernment. Secondly, we're going to talk about what I wish more people understood about evolution. Raise your hands if you heard someone say, basically, if you don't believe in evolution, it's just like you're ignoring the evidence and it's stupid, there's a tsunami of evidence, and everybody has to believe in evolution. I've heard it. Now raise your hand if you've heard people say there's not a single shred of evidence for evolution. I'm sorry, these can't both be true. So we're going to talk about how do we rectify these two positions? Why do we have people coming to such polar opposite views? So then we are going to talk about what Darwin got right. In my book, when we were talking about discernment, I think it is always important to look for what someone got right first. Because no one ever does a theory or has a worldview thinking this is totally wrong. They usually have some kind of motives. They usually have some kind of legitimate study. Darwin had some legitimate study that he did that was very, very good. And we want to recognize where he got it right. The golden rule, I say, of apologetics is to treat someone else's ideas the way you would want yours to be treated. And that means treating them fairly. And treating them the way that if I were to describe this person's point of view, they'd say, yeah, that's what I believe. Because most of the time what you hear people do is they describe what's called a straw man version, where they say, oh, you just believe your great-great-grandfather was a monkey. I'm sorry, there's no evolutionist out there that would ever say that. That's kind of creating this really, it's like creating a straw man, like a lifeless straw man, and then going boom, boom, ha, I want him to fight, woohoo! But you're doing that with someone's idea. We want to treat their idea the way they would want their idea to be presented. And then finally, we're going to go into what Darwin got wrong, because there's some legitimate stuff that he got wrong there. So those were I would say that's kind of the route that we're going to take. This slide here is going to be kind of the scenic landmarks that I want you to be looking for along this talk. So number one, I want to understand that belief in evolution is not an all or nothing thing. Everybody that raised their hand has heard of this all or nothing presentation of evolution, of there's not a single shred of evidence, or it's all the evidence. That's all or nothing thinking. Instead of saying, well, there are some things that do support evolution, there's some things that don't. That would be a fair presentation of it. Number two, learning how to spot buzzwords and ambiguous words. I cannot tell you enough that if you learn how to do this, you will not be duped when you get into your college science classes. When you learn to hear what they're saying, and how they're masking the stuff that they don't know. It's like, okay, I see what's going on here. A lot of times, sorry, I've got some, hold on, I'll turn my mic off just for a second to give it like a good clear. Hopefully that's better. So a lot of times scientists use buzzwords when they're trying to mask a mechanism that they don't understand. So they'll just kind of use this buzzword. We're going to look how to identify that. Third, and this is something that I want you drilled into your head over and over again. Science tells us nothing. Scientists tell us things. Whenever you see an article that says science says, just remember, science is not a person. Science can't say anything. Every single piece of data that you have out there can be contested with people, and especially with evolution. You can have the exact same data, and you'll have two wildly different conclusions. So science is silent on the issue. It's the people interpreting the data, and it's the people who have a worldview, which we go all into in the Mama Bear book of what are these worldviews that are interpreting the data. It's a big difference between the Christian worldview and the secular worldview. And then finally, this is also a huge one. Anyone who tells you that there are no limits to the creative power of evolution is speaking beyond the evidence. And this is where I hope to get into a little bit more of the technical stuff towards the end, and hopefully we can get there. We want to stick with what is evidentially supported. We want to stick with what is experimentally supported versus specular science, where they say, well, this must have happened. This has to have been what happened. You need to be able to learn the difference. When I was in my evolution and genetics class in grad school, I remember them talking about things of, we have observed this, and this, and this, and this, and then they would go on to, and then this is possible, this organism then later became, all of a sudden the sperm whale became into a horse, and they had the same conviction, and they talked about it with the same certainty, but it lacked any of the evidence, but you would never know it based on the tone of their voice and the certainty that they presented it with. So if you can learn how to see through those things, you will be ahead of all your peers. So first off, there's a quote that I love by Voltaire called, if you wish to converse with me, define your terms. One of the big things that I see happening a lot of times when people are in disagreement is that they're using the same word in two different ways. Now there's two different ways this can happen. Number one is called the equivocation fallacy, which we'll talk about in the next slide. The other one is chapter 4 in the Mama Bear book called linguistic theft. It's where people are purposefully taking words, changing the definition, and then putting them back on you, saying, oh, well, you believe in this, so, like the word love. Your God says he's a God of love. I'm going to go over here, change the definition of what love means, and then I'm going to hold you to that standard. So these are the two different ways. So you need to really define your terms when you're talking with people. A lot of the arguments my husband and I have had, we have discovered after, 45 minutes into the argument that we actually agree. We were just saying it in different ways. So, do it at the beginning rather than at the end, 45 minutes later. So the three words I want to talk about are Darwin, it should be Darwinism, Neo-Darwinism, and Naturalism. So classic Darwinism versus Neo-Darwinism. Has anyone ever heard the difference between these two? Okay, good. So first. So classic Darwinism is just going to be your basic survival of the fittest. This is what you've heard from basically kindergarten on up, that we have change over time, that we have more individuals that were created that can survive, and we'll go over the whole thing of just classic Darwinism in a second. So we have these two dudes right here. Who can identify the one on the left? That one's easy. Who can identify the dude on the right?
Is his last name Wallace?
No, but he is coming up. I'll give you a hint. Pea plants. You're close. Punnett squares. I know, everybody knows who it is. It's Gregor Mendel. So, Gregor Mendel is the one who discovered just the ratios, that things tend to stay the same. And actually, Gregor Mendel's work was ignored for about 100 years. Do you know why? Because it disagreed with what Darwin was saying. This is one of the ways that you can see that when you have science that is really holding on to a paradigm and they don't want to let it go, they can reject legitimate science because it doesn't fit with the paradigm. He just kind of went into obscurity for 100 years till someone rediscovered his theory. Because the difference that was going on is Darwinism. Darwin was saying things change over time. Mendel was saying, well, they basically stay the same, and we can even see the ratios. They stay the same in, and they were saying, nope, we're sold on evolution, so yours must be wrong. But later on they discovered, well, actually maybe it is right. So basically, the thing with Darwinism and evolution in general is it's basically anything you want to throw at it, it's like, okay, sure, we'll incorporate that. So Darwin and Mendel had a beautiful little baby, and that one came into Neo-Darwinism. So Neo-Darwinism is what a lot of your schools will be talking about right now, and that's going to be the mechanism behind evolution, where it is saying that it is evolutionary change comes via random mutations in the genetic code, some of which are beneficial. I don't have time to go through this right now, but if you are curious about this, I want you to talk to me afterwards. There is actually a software called R that we use in grad school to model this, and if you're really curious about how well it worked, come ask me afterwards, because it was a really fun experiment, and I had fun messing with my professor. And then finally, naturalism. Naturalism is just something you need to be aware of what it is. This is the philosophy that undergirds everything. It's saying that, so materialism is the belief that material causes are all there are, or that this world that we have, the material, is all that there is. And then naturalism would be that natural causes alone are sufficient to explain everything. So even if it looks like, hey, it doesn't look like a natural cause can explain this, they will still base their science on that philosophy. And part of chapter 6 is I talk about the difference between naturalism and supernaturalism, what it comes down to. And what it essentially comes down to is someone saying, my faith is more scientific than your faith. Do you think that's a legit statement? No. If everything is based on a philosophy, it's ultimately based on a faith that philosophy is true. And so don't let people bully you into thinking that their faith is more scientific than yours, because it's not. So what do I mean by discernment? Again, the entire chapter 3 of the Mama Bear book is based on discernment. And what did I say was that when you're doing discernment, what's the first thing you need to make sure you do first? Yes, yes, get your definitions right, Ashley, that's very good. So what's the second thing you need to do? What did they get right? Exactly. So I kind of use the example of stir fry. If someone were to give me stir fry, I love stir fry, but there's one thing I would do if I saw this. I would pick out all the peas first. And it's not because I don't like peas, I actually like peas, but as my grandmother used to say, peas don't like me. So I've got an allergy to peas, a random allergy to peas. So what I am doing is I'm not accepting all the food, and I'm not rejecting all the food. I'm taking out the things that are good and nourishing for me, and I'm picking out the parts that are not. Now, you can't do that with everything. Like, if you're listening to a song, you can't just like sit there and selectively close your ears for certain things you don't want to hear. And the discernment chapter in here is all about the chew and spit method, which is a little different than the pick and stuff out method. But it's still a method of discernment. We have this idea that if we just categorize things correctly, then we can turn our brain off. But really, in real life, we do not live in a comic book world. Not everything is black and white. We have to know how to discern the good, discern the bad, accept the good, and reject the bad. That is discernment. It's those 4 steps. Identify the good, identify the bad, accept the good, reject the bad. Because good and evil are often mixed together, because eventually what happens if you are told that this whole thing over here is all wrong, and one day you find out there's some things that are right in it, the people telling you that they were all wrong, they seem like a liar now, right? They're either a liar or they just don't know what they're talking about. You're not going to go to them for advice anymore. Don't be that person. Be able to identify where things are right, and then also identify where they're wrong. We have an epidemic in our country of people not being able to do this. If you watch the news, we have an epidemic of people not being able to admit when the other side has a good point. Let us not be those people. Because, okay, so I did actually have slides. So the chew and spit method I talked about, discernment requires some things. Yeah, truth, reality, you have to see things how they are. You have to see the good, you have to see the evil. Because the thing that we want to know is there is no autopilot in the Christian life. Again, when people want to just categorize something correctly and then they can work on autopilot, it doesn't work. You have to be aware of everything that you are doing, everything that is coming into your mind. So some ways that we need discernment with Darwinism is, number 1, recognize buzzwords. And these are often, I'm going to use a big $2 word here, teleological. So I want everybody to say teleological with me. Teleological. So teleological is not something that you're going to hear you're in your college classes, usually it's something you'll hear in something called intelligent design. Has anyone here heard intelligent design? So teleological means something that is purpose-driven. It has a goal. So, for example, trying to think of an example. There's a purpose for eating. It's to nourish your body. There is a purpose for sex, which is in procreation. There is a purpose for going to school, which is knowledge, not just getting a degree. So also in the biological world, we see purpose-drivenness there. So Richard Dawkins has a statement. He says, biology is the study of things that give the appearance of having been designed for a purpose. Don't trust your lying eyes. It's just the appearance of having been designed for a purpose. Likewise, Francis Crick, the co-discoverer of DNA, said, the scientist must constantly keep in mind that what he sees was not designed for a purpose, but rather evolved. If you're having to constantly tell yourself, don't believe what I see, don't believe what I see, I think there's a problem there, in my opinion. So a lot of times they'll use these teleological buzzwords. So the explanation of a phenomenon by the purpose it serves rather than the postulated causes. So, for example, in our botany class, they were talking about the purpose of the veins that are in leaves. And they say, well, if the leaves were growing bigger, they needed a way to have the water get to further parts of the plant. What they're talking about is a need that the plant had and the way it developed a purpose, that growing those veins had a purpose. How does something mindless have a purpose and have a goal that it meets? Does some mindless process be like, woohoo, goal achieved? No. So a lot of times the buzzwords, this is where you'll see them happen. So here's a couple of them that I always hear in my biology classes. The development of. Whenever you hear the word development, it usually is you're hear it talking about an apartment complex going up or maybe a new theme park that's going up. Never is it just some random some sort of chaos that was happening. The word development insinuates that there is a mind involved, but yet they're using this word to describe a mindless process. Be aware of that. It is impossible to talk about biology without teleological words, purpose-driven words, and that should tell us something. My favorite one that I had, my plants class professor always used the word learned, and then plants learn to have seeds. They learn to be vascular, and I remember just kind of sarcastically thinking, of course I would never say this to him, I was like, how did they learn this? Did they take your class? Plants can't learn stuff. I'm sorry, so this would be another teleological word where they don't know the mechanism, but they're using a buzzword to say this has happened, we don't know how it happened, but it must have happened. Adaptive, this one you'll see basically from kindergarten on. Whenever you hear the word adaptation, what does that make you think of? It's like something wasn't like something before, but then it adapted and it became like that it changed. The word adapted itself has the connotation of change built into it. In essence, whenever you're talking about an adaptation, you're talking about something that makes an organism well suited for its environment. For example, a cactus has something called a really thick cuticle. It holds the water within it, which is really good because when you're in the desert and you don't get a lot of water, you need to keep the water that you've got. So they would say an adaptation for a cactus, cacti, is this thick cuticle. But again, that idea is like, oh, it didn't used to have a cuticle, and then it learned to have a cuticle, and now it has a cuticle, and now it's really well adapted for its environment. Or this is how God created it, because he created cactuses, cacti, whatever, to live in arid environments. Again, these are buzzwords that they're using that have goal-directedness. Or just the simple phrase, evolved to have. You have no idea how it happened, we just know it evolved to have this. One of my favorite ones that they talked about was the swim bladder. Swim bladder is like such an amazing design in fish. You're nodding, you know, you've studied this then. The swim bladder is like this little ball of air that's inside a fish that it can actually release gases into its bloodstream or take gases from its bloodstream to put it into this swim bladder, which allows it to rise and lower in the water. Think about if a fish didn't have that. It would either be like sunk on the bottom or it'd be floating on the top. It would have no control. I want to know how you think that evolved. How did that come piecemeal? So ways we need discernment with Darwinism, again, we've got to spot ambiguous words, the equivocation fallacy. And here's one of the biggest ways that you're going to see the equivocation fallacy. Equivocation fallacy is when you're using the same word in two different ways. Different from linguistic theft because they're not completely redefining it. These are kind of both legitimate ways to define it, but they're using it at the same time. So look what this guy is saying. He says, I know evolution is true because I see evolution happening all the time. I hear this in a lot of scientists. But look what the first evolution is. You've got some kind of, I don't know, some kind of protozoa right there on one side going all the way to man. This is what's called molecules to man evolution. And in some circles, we'll call this macroevolution, although the terms micro and macroevolution, if you have questions about that, ask me afterwards because those are also being co-opted in college. The second one here is like two different dogs. This would be kind of like microevolution. You see small changes happening. So what happens when someone says this, and then you hear the person saying, no, there's not a single shred of evidence for evolution. They treat you like you were denying this. Oh, really? So we don't see small changes. We don't see finch beaks get bigger. What an idiot you are. When the person is actually denying this one, yeah, I don't see how a sponge can turn into a tree frog eventually. And they are in the same lineage, by the way. So this is what's happening with the equivocation fallacy. So ways we need discernment, again, the ambiguous words. Just think of evolution, change over time. That's what you'll always hear. What do they mean by change? Are they talking about finches with different finch beaks? That would be change over time. Just side note, the whole finch beaks thing, once the rain returned to normal, the finch beaks actually returned to what they originally were. I've got a biologist here. So it was only a temporary change. It didn't even keep going. It was just temporary. And then I decided to look at a project that I had to teach for one of my biology classes. The sponge and the tree frog, they're literally in the same lineage. So if you can imagine what a sea sponge looks like and think, just give it enough time and it can turn into a tree frog. That's a different kind of change over time. Also the word species, and I want everybody, anyone that's going into sciences, I want you to understand this. The phrase, we've never seen one species turning into another. The problem with this is there is no consensus of the definition of species. You would think after all these hundreds of years of the scientific revolution that we would have a definition of species, right? We don't. We can have, basically what they've kind of turned it into is things that either don't mate, can't mate, or, yeah, it's basically don't mate or can't mate. But think about this. You'll have two sets of birds that migrate from north to south. One of the birds starts taking east to west route. The other one starts taking the west to east route, or the west to south, sorry. These are now classified as two different species because they don't come in contact with one another. If you were to grab two of these birds and put them in a cage together, there's a possibility that they still could mate. They may not want to. But when I look at these birds, they're literally identical. It's just their migration route. According to some scientists, these are two different species. So when you hear scientists say, we've observed species turning from one species to another, that's what they're talking about. Stuff, not just that, stuff like that. Now, a lot of times what a well-meaning Christian is meaning is, I've never seen a dog turning into a cat. We see kinds that were created at the beginning. I've never seen one kind turn into another kind. And again, yeah, I kind of explained that one already. So we have to understand what people are meaning by species. Again, define your terms. Ask them what they're meaning by species. And know that there's no general consensus. And don't use phrases like there's not a single shred of evidence for an evolution. I was actually endorsing a book several years ago where the woman meant well, but she had that phrase in there. I said, you've got to take that out. Thank goodness she took it out, and I was able to kind of help with the science section on there. But that's the kind of thing that when your kids, well, I'm talking to a bunch of youth, when you hear your parents say stuff like that, or you hear the church say something like that, think of maybe some of your unbelieving friends, or friends later on that are going to walk away from the church. When they hear that, and then they go and they find this evidence for evolution, they're going to say, the church doesn't know what they're talking about. The church is anti-science. I don't want to be part of the church. Was anyone here part of the doubt class yesterday? Okay, so y'all remember what we were talking about when people just lose the confidence to be able to believe someone because they hear something that they think is a lie. So let's talk about where Darwin got it right, because again, I think that's the respectful thing Number one, Darwin's inability to hide his understanding of Romans 1:19 through 20. So Romans 1:19 through 20 talks about how God's invisible qualities, his divine nature, is all clearly seen from what has been made so that man is without excuse. It is interesting. I'm going to show you a quote in here that basically you could just replace natural selection with God, and it's like, wow, he really nailed all of God's attributes. Like, way to go, Darwin. Number two, problems with the Cambrian explosion. Has anyone heard of the Cambrian explosion? A couple people, we'll go into that. Three, he had a really well-articulated requirement for falsifying his theory, and it's one that I really wish that modern evolutionary scientists would stick with what he said. Like, if this doesn't happen, this isn't true. And then finally, the data collection he did to support natural selection was second to none. It was incredible, the amount of data collection he did. I would dare say it was excellent. And I think anything that really is done with excellence needs to be praised, even if it's done by a secular science or a secular scientist. So first off, Darwin shows his cards. The man understands worship. So this is a quote that I've never heard anyone else give this one but me, and I think it's funny. So he's going through Origin of Species is a bit of a tedious read because the first part, homeboy is obsessed with pigeons. And when I say obsessed, I mean he is counting the hairs between pigeon toes. I cannot imagine being married to this man. Like, he was obsessed with pigeons. I don't know why. But he goes from this really meticulous data collection, and then all of a sudden it changes. And on anything that I give you, I'm not going to give page numbers because Origin of Species has been put in so many versions that page numbers don't matter. I'm going to tell you approximately where it is in the book because I think that's more helpful. But here's what he said. Can we wonder then that nature's productions should be far truer in character than man's productions? That they should be infinitely better adapted, should plainly bear the stamp of a far higher workmanship. It may be said that natural selection, not God, natural selection, is daily and hourly scrutinizing throughout the world, rejecting that which is bad, preserving and adding up all that is good, silently and ostensibly working to the improvement of each organic being. Oh, we see nothing of these slow changes, so imperfect is our view. Natural selection can only act through and for the good of each being. What do y'all think about that?
That was very oddly eloquent.
Say it again.
I said that's a very oddly eloquent way to describe a natural process.
It is. Is this the kind of thing that you're like, I feel like I've heard Bible verses that talk like this before? That, talking about, he really nailed a lot of attributes of God. Look at this. Nature's productions are far truer in character than man's productions. God's ways are so much higher than our ways. That they should be infinitely better adapted. Again, God's workmanship is so excellent. Scrutinizing, that God is constantly looking and working in his creation. Rejecting that which is bad, preserving and adding up all that is good. Can blind process reject and preserve? Or is that someone making a choice? That's a choice right there. Silently and ostensibly working, it's just this benevolence. Oh, the benevolence of natural selection. So we should really be so thankful for natural selection. And it can only act through and for the good of each being. That phrase right there, that is benevolence, that is goodness. He is identifying all these attributes of God, but he's ascribing them to natural selection. And this thing is just this paragraph, which is kind of randomly put in there in the middle of it, and I don't know why no one's ever pointed it out before, because I think about, and even just saying that we can't even understand it. It happens so slow. Just natural selection's ways are just so much higher than our ways, we can't possibly begin to explain it. All hail natural selection. And that's essentially what's going on here, but at the same time, he understands worship. So why is this important? What we're going to start hearing in your classes is something called the bad design argument. Bad design says we find something that doesn't work perfectly, and therefore we say this is bad design. If it's bad design, it couldn't possibly be designed. Basically, all of us are held together with the biological equivalent of duct tape and bubble gum. But is that really what we see in design? I think Darwin, especially, if you look at how much respect he had for the natural world and how well put together he saw it, that right there tells us that the people later on saying, oh, we have bad design, and I'm using this example right here, this is considered an example of bad design, the fact that our trachea and our esophagus are so close together. And I can't go into all the refutations of that, but it turns out that that's actually a pretty good design, or something called the panda's thumb. Have you ever heard the panda's thumb? It's this kind of weird gimpy appendage that they thought there's no way that was designed well. This is like it's like people put it up as such a poster boy of bad design that they have websites called the panda's thumb and books called the panda's thumb. Well, lo and behold, we discovered that the panda's thumb is the most efficient bamboo stripping just thing in existence. The bamboo, or the panda eats bamboo. Lo and behold, his thumb is the most efficient bamboo stripping, I don't want to say machine because it's not a machine, that we know of. So even just people talking about the panda's thumb, it's like, ugh, you're so behind in research. So problems with the Cambrian explosion. There is a Time magazine, and I can't remember from where this was, but even Time magazine is recognizing that evolution had a big bang. And when we say big bang, we mean a whole bunch happened in a really short period of time. So we have kingdom, phylum, class, order, family, genus, species. That's how we usually classify everything. So kingdom is the highest one. So do we have, I think they have 3 kingdoms now. They used to have 2. I won't go into all the details. Phylum is the second biggest one where you'll have the most diversity in it. The thing that when we ever talk about animals, we usually use the genus and species. And those are the most specific. But the phyla and the kingdom are the least specific. So you can have a really broad number of things within the phyla that look nothing like each other, but they're still classified the same phyla. So Cambrian explosion, we saw 2/3. So basically 26 of all the major phyla, remember these are the really diverse species, really diverse organisms that appear with no ancestral or intermediate form. They just, boom, appear out of nowhere. And this is called the Cambrian explosion because it happened so fast that, scientists don't know how it happened. So actually, this is kind of a funny story. There's a joke where this man goes into a doctor's office and he's telling the doctor, I think I'm dead. And the doctor says, okay, what test can we do to prove that you're not dead? And the doctor says, do dead men bleed? And the guy thought about it and said, well, no, dead men don't bleed. So the doctor took a needle, pricked him, and of course the guy started bleeding. And what was his conclusion? I guess dead men do bleed. He couldn't be convinced that he wasn't dead, even with that test. So he thought, oh, I'm just going to change my evidence to match what I really think is true. We see the same thing happen in evolution. So evolution talks about how slow and gradual things have to happen. When they discovered the Cambrian explosion, so instead of saying, oh, maybe evolution didn't happen, they thought, oh, I guess evolution can happen in the blink of an eye. And they actually have a name for it. It's called punctuated equilibrium. So basically in biology, if you don't understand something and if you need a mechanism to just kind of mask that you don't know what's going on, just give it a name. The whole scientific community will say, yes, punctuated equilibrium. Very good, very good. And this is what we see happening with this. So this is the examples of the phyla that show up. We have everything from sponges to jellyfish. Annelids are kind of worms, mollusks, all the way over here to insects. So think about compound eyes. Think about how complex compound eyes are. Eyes are one of those things that as evolution were true, we're going to start with kind of like these euglenoid light spots. And it's going to go to maybe like a really simple eye and all this. But no, we see compound eyes, boom, coming out of nowhere. We see layered, multi-segmented body plans, boom, coming out of nowhere. But Darwin had some thoughts about this. Darwin's Doubt is a book written by one of my favorite scientists, Stephen Meyer. So this isn't a quote from his book. The quotes are actually from Darwin. And again, I don't give you page number, I give you approximate location because that's more helpful. So Darwin is saying, but as by this theory, innumerable transitional forms must have existed. Why do we not find them embedded in countless numbers in the crust of the earth? So Darwin was actually aware of the Cambrian explosion and the problems, which is where this book Darwin's Doubt came from, because Darwin was saying, yeah, maybe my theory isn't right because I'm not seeing what I expect to see. But he kind of had faith. Again, this is at the beginning of chapter 6 of Origin of Species. Why then is not every geological formation and every stratum full of such intermediate links? Geology assuredly does not reveal any finely gradated organic chain, and this, perhaps, is the most obvious and gravest objection which can be urged against my theory of evolution. Way to go, Darwin. You found a way to falsify your theory. Nowadays, we just give it the name punctuated equilibrium and keep the theory. So let me show you some examples. It was a small problem in Darwin's time. It has now become a huge problem in our time because we don't have just one, not two, but 3 different places that are called shales. So we have the Burgess Shale in Canada, we have the Sirius Passet in Greenland, and we have the Xinjiang in China, which the Xinjiang one is one of the most recently discovered. And what we've discovered is this problem isn't getting better, it's actually getting worse. We're discovering more and more and more places where just this explosion of biological diversity happened in what would be considered evolutionary blink of an eye. So again, what he defined would falsify his theory. There was a reason why I showed you that Rube Goldberg machine, is because he specifically talks about organs that he doesn't think would be able, well, I'll go ahead and go into that. He said if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down, but I can find no such cause, or no such case. So that's about halfway through chapter 6. So I don't think we need to just talk about an organ. In my opinion, after studying biology, I think processes in the body are probably one of the most, probably the most damning evidence, I would say, to the theory of evolution. So y'all saw that Rube Goldberg machine at the beginning? The reason why I show that to you is because usually when I ask people what a Rube Goldberg machine is, they're like, oh, what? That is actually a really good analogy for what is called a biological cascade. Cascades in the body are when you have one chemical interact with another, which interacts with another, which goes over here, which interacts with another, and it just creates this whole chain of events that eventually ends in something like the blood clotting mechanism. And so I recommend Darwin's black box for that, and I'll show that in a second, but I just want to show you one of my favorite things, the thing that really made me fall in love with biology, the thing that I thought I want to know more. It's going to be a little bit better version of this. Can anyone tell me what's going on in this picture? Yeah, it's replication. Yeah, DNA replication. So I want to show you, this is narrated by Stephen Meyer. I want you to see what all goes on, because like the more you get into science, the more details they give you, and then you're like, oh wow, this is way more complicated than I thought. So hopefully the sound is loud enough.
In 1957, Francis Crick first proposed that chemicals called bases along the spine of the DNA molecule function as alphabetic characters in a written language or digital characters in a machine code. This animation shows how this digital information directs protein synthesis. First, a large protein complex separates the tightly wound strands of the DNA to prepare it to be copied. During this process of transcription, a protein complex called a polymerase produces a single-stranded copy of the original instructions. Here we see this copy, a messenger RNA molecule, being constructed inside the polymerase as individual bases are positioned and added to the growing strand. Now we see the polymerase in action from the outside as it spits out the messenger RNA transcript. Next, this RNA transcript approaches and passes through a molecular machine called the nuclear pore complex, an information recognition device that controls the flow of information
It chooses
in and
what
out
goes
of the
in and
cell's
out.
nucleus.
Like, it pays.
Now we see the genetic assembly instructions on the messenger RNA approaching and arriving at a two-part chemical factory called a ribosome, the site of protein synthesis. As the messenger RNA transcript passes through the ribosome, the process of translation begins. During translation, a mechanical assembly line builds a specifically sequenced chain of amino acids in accord with the instructions on the transcript. These amino acids are transported from other parts of the cell by molecules called transfer RNAs, which link specific sequences of bases to corresponding amino acids. The sequential arrangement of the amino acids determines the type of protein constructed. When the construction of the chain is complete, it is transported to a barrel-shaped machine that helps fold it into the precise shape required to perform its function.
So it's being put in a specific shape because it's going to act as a lock and key mechanism to whatever it's reacting with. If it's not in the exact shape.
After the chain is folded into a protein, it is released into the outer cytoplasm to do its job in the cell.
So our body, that is just one of them. And I have to say, I'm a nerd, I will own it. I'm obsessed with the idea of protein synthesis because of how complex it is. Because it's like you see everything coming and it looks like it's just planned. Oh, you just place it here. Well, I mean, it doesn't have, it can't say, okay, go grab me a thymine, go grab me a, this kind of, go grab me a lysine. It's like all of this is happening just seamlessly in your body as we speak. And when we say protein, people think protein, oh, meat. Everything in your body, we're talking about hormones, we're talking about parts of your cellular structure is made up of proteins, and this is how they are made. And if they're not in the exact right shape on 4 different ways, then they will not work. In fact, this is where a lot of diseases come, is when the protein is not folded correctly. So it's like having to cut the key to where it is a specific shape. Does this look like something that happened by slight successive modifications, or does this look like the Rube Goldberg machine where you take one of those dominoes out and it stops in its tracks? The purpose of the Rube Goldberg machine is if you take one step out of that Rube Goldberg machine, that whole process stops where it's at. We have thousands of processes like this in our body. It boggles my mind that biological scientists are still married to this idea that this happened on its own. And I really think you have to be, number one, indoctrinated into believing this. You have to have already accepted naturalism as the only explanation of everything. And I really think there is a spiritual blindness that is going on that absolutely blinds them to the fact that, oh my gosh, can you see how this is not possible? Sane, rational. The people that are less educated often can see that didn't happen on its own, because they don't have just years and years of people telling them, yes, it happened on its own. Everybody repeat, it happened on its own. It's like this, I don't know. It just boggles my mind that we have so many atheists in the biological community. So this one right here is an example of the blood clotting cascade, which Darwin's black box goes into in depth. And he gives really great analogies so that you understand them, so he's not just talking about a bunch of random chemicals. So Darwin's theory of natural selection, I told you, I'm going to go quick through this one. So this is not controversial. I don't care if someone is the most conservative scientist, young earth creationist, all the way to evolutionary scientist. Most people will agree on this one. That variation exists within populations. And I want y'all to, there's going to be circular reasoning at the end. Y'all know what circular reasoning is? It's where you use something at the beginning to explain something at the end. So variation exists within populations. No one can test that. We all know there's different types of dogs. Variations are inherited. We've already accepted Gregor Mendel. Go Greg. Organisms produce more offspring than can survive. Everybody's seen the sea turtles being born. If all the sea turtles that were born actually survived, the sea would be nothing but sea turtles. So more are born than can survive. The organisms which have variations which are better suited to the environment survive and reproduce via competition and predation. So the antelope that runs faster, doesn't get eaten, goes on to produce other fast antelope. Not really contentious there. And then finally, populations change to reflect the survival of the fittest. You have to remember, when people are talking about evolution, they're not usually talking about individual organisms. They're talking about populations that are changing. So the problem with this is that, problems with natural selection is this is a chicken and the egg scenario. we have used as a mean to explain diversification the existence of diversity. So if you say all the different species, all the different phyla, all the different variations of organisms that we see are due to natural selection. What's step one in natural selection? That variations exist. So we can't say we get variation because we had variation. No, the variation had to come first. Again, this is literally a chicken and egg scenario, and it's amazing how many people aren't really recognizing this. So their solution, and again, this is where our neo-Darwinism comes in, is, okay, so if we need to insert more variation into a species, then we're going to do that via mutation. Mutation is when the cell is replicating and it's like, oops, I meant to put in this one base code and I put in a different one. Oh, look, it makes the organism better. Okay, first off, that rarely happens. Most of the time it's either neutral or the cell will actually kill itself because it's like, spell checker just says that's not correct. So the problem, it's very hard to get a beneficial mutation. And two, it's even harder to get it to outcompete all the others to the point of fixing in a population. Remember when I talked about that software R, about how this is modeled? Again, come talk to me afterwards. To fix something in the population means that it becomes the norm in the population. Because think about it, if you have a population of 10,000 individuals, we'll say bacteria, and one of them has a mutation that maybe has a benefit. It has to have a benefit that's good enough to outcompete all 10,000 of those other bacteria in order to become fixed in a population, means that it becomes the norm. Very difficult to do. So where did Darwin get it wrong? This is, of course, where we all came from. Where did he get it wrong? We're kind of pointing them out as we go. Excuse me. He wrongly attributes God's attributes to natural selection as if it were a benevolent cognitive being. Natural selection is a process, not a benevolent cognitive being. God is a benevolent cognitive being, meaning he's good, he has a mind. That's God, not a mindless process. Number two, we have a problem with requiring pre-existing variation to explain the origin of variation. Again, we've got circular reasoning going on, which they solve by adding in mutation, which I can't have time to go into. Is very, very difficult to get to fix in a population. But the number one thing, I would say, just numero uno, that Darwin got wrong was this. He assumed that evolution was limitless. In fact, he has several places in his book, I can't remember if I have, I guess I do have a text in here, how Darwin saw it. What limit can be put on this power acting during long ages and originally scrutinizing, there's that word scrutinizing again, the whole constitution, structure, and habits of each creature, favoring the good and rejecting the bad? I can see no limit to this power. So that's in chapter 14 of Origin of the Species. This is the number one I think he gets wrong. It's also the number one thing that I think modern evolutionists get wrong. So what we don't know, except for that guy did because he said his name, is that there was a co-discoverer of evolution. His name was Alfred Russel Wallace, but you will not hear about him. We kind of consider him the father of intelligent design. I kind of find that whenever there's a new idea, that the Lord kind of puts it in different people. I feel like knowledge, I like photography and technology and just all these things that we see. Calculus. Calculus was simultaneously invented on 2 different continents. It's almost like the Lord slowly revealing knowledge, and he reveals it to multiple people. So I do think that natural selection has merit. Alfred Russel Wallace agreed, but he did not agree with the limitlessness of it. So here's what he said. He said, it will therefore probably excite some surprise among my readers to find that I do not consider that all nature can be explained on the principles of which I am so ardent an advocate. He was a big fan of natural selection. He's like saying, I know this didn't come as a surprise, but I don't think it can do everything. And I'm now going to state my objections to place limits on the power of natural selection. Just surely as we can trace the action of natural laws, I mean, we can tell when natural laws are working. Like in that Rube Goldberg machine, that whole machine was acting on natural laws, was it not? Was that machine put together by natural laws? No. So like he says, just as surely as we can trace the action of natural laws in the development of organic forms, so surely we can trace the action of some unknown higher law, he called it a higher law, beyond and independent of those laws which we have any knowledge. This is where he is bringing something supernatural. We can look at that Japanese Rube Goldberg machine, and we can explain through physics every single motion that it does. What we can't explain is how it got put together. That requires something outside of natural law. That requires a mind. And this is what Alfred Russel Wallace was going for. So even though he and Darwin discovered this at the same time, people said of Darwin's theory, it is now acceptable to be an intellectually fulfilled atheist. It had people who did not want to believe in God, and this was finally the way that they could get around that. So that's why you don't hear about him as much, but you will in Intelligent Design. And why do I think Darwin got this wrong? Number one, it's not experimentally or evidentially supported. This limitless creation is not experimentally supported. We have the problem of pre-existing variation, the problem of sexual reproduction. I'll try to go quickly through these. This right here is something called the Lenski experiments. Anybody that has a biology class in college is going to learn about the Lenski experiments. It received the Nobel Prize for supposedly evolution happening before our eyes. He had it lasted like 12 years. He's had some like 80,000 generations of E. coli that he would take a few out of one petri dish and put in another, let them reproduce, and then take some out. And then he saved all the different variations. And if you look right here, the steep line right there, kind of on the left, is the mutations that are going on. He's saying, wow, look, we're seeing it change before our eyes. But what do you notice as time goes on? It kind of limits out. Exactly. There's nothing left. And what it comes down to, and this is something also you won't hear about, the big new species of E. coli. First of all, these are all still E. coli. I'm not even sure if you could call it a new species of E. coli. It had a broken transporter protein. And they're like, look what we've created. It would be the sense of like blowing up a bridge and then saying we've created a new country because there's no way to get from one. I found a new land because we blew up a bridge between these two lands. That's essentially what he discovered. So the point is here, we can see the limit. If we think natural selection is limitless, we can be like, no, I think I see the limit. Right around there, there's the limit. The biggest mutation is a broken transporter protein. And here's a quote that just says, there's a creativity in the genome that is inexhaustible, despite the fact that just about every spot in the microbe's DNA is mutated by now. Does this look like inexhaustible? No, it looks exhausted right around there. I don't have my little pointer thing. So this is how you can have scientists looking at the same data and coming to different conclusions. So if you didn't see this graph and you just heard someone talking about it, you think, wow, we have seen evolution happen before our eyes. We have seen a new species being created. And he got the Nobel Prize for this. So next is going to be the problem of pre-existing variation. And so I'm going to be kind of quick with this one. One of the things that we've also heard that is evolution happening before our eyes is antibiotic resistance. So when you go to the doctor, they always tell you, take the full antibiotics, right? Because what happens is if you take part of the antibiotics, you start feeling better, then you're like, oh, I don't need the rest. Well, the bacteria that wasn't responding to that wasn't responding to the antibiotic, all of a sudden doesn't have anything kind of hit it anymore, so that it replicates out of control, and now you have a whole population of bacteria in you that is less responsive to the antibiotic, and you have to find a new antibiotic. They thought this was something, they're like, look how grand design that these microbes they can mutate before our eyes. Okay, so taking the age of the Earth outside of the picture, we're just going to go on what the secular scientists are claiming that they found, okay? So we're not going to get a debate on the age of the Earth. So this is an actual article that is, where was it published? I can't remember. But it's called Antibiotic Resistance is Ancient. And here's one of the quotes from it. These results show conclusively that antibiotic resistance is a natural phenomenon that predates the modern selective pressure of clinical antibiotic use. The reason they came to this conclusion is there's something called ice cores. You have permafrost kind of up in the places where it's super cold in the tundra. They were able to drill down. It's kind of like, have you ever taken you have a Slurpee and you put your straw in it and you cover the top and pull it out and eat it? That's kind of like what an ice core is. You can get whatever's at the bottom of the Slurpee. If you wanted to do like layers of your Slurpee, you can get all the layers by taking a little core out of that. So that's what they did. And it's supposedly, I think, a 30,000-year-old ice core. They supposedly drilled down what would be essentially 30,000 years. And what they found at the bottom of what they claimed to be 30,000 years, lo and behold, there was bacteria that was penicillin resistant. What does this tell us? We didn't create some new type of bacteria that was resistant to penicillin. Penicillin-resistant bacteria already existed. We just cleaned out all the other bacteria when we started using penicillin. Nothing was evolving to create new things within these microbes. It already existed. So pre-existing variation a lot of times is difficult to find. Are we dealing with something new that has evolved, or are we dealing with pre-existing variation? It's very hard to find pre-existing variation, especially among something like microbes, but we did. And so we can assume if it's happening there, it's happening other places. And then the problem of sexual reproduction, I use a very technical explanation of this. My husband loved Legos when he was growing up, and he told me this problem that he had. So we have a godson that also loves Legos. So every year, he can only build so many things with the set of Legos he gets. So we just get him a new set of Legos every year. But my husband told me this horrible experience he had when he was a kid where his parents tried to get the discount Legos. Does anyone know what those are called? Duplos. Yeah, that's right. And what did he discover about the Duplos?
They don't fit.
They don't fit. Even if you wanted to put the Legos and the Duplos together, they discovered these were not compatible. So what we have with the problem of sexual reproduction is that there's only so much variation you can put into a species. Remember our E. coli, if you had every single place mutate, it eventually will, veer off, and you still pretty much have E. coli, but maybe with something broken. When you get to animals and you get into the animal kingdom, there's only so much variation that is currently in that animal. In order to create something new, you have to introduce something that has more variation that is outside that organism, that kind. But what we find is that when organisms are different enough, they either won't mate, can't mate, or if they do mate, then it's sterile. Think about donkeys and horses are sort of close enough to where we can make them mate. And that's where you get a mule. Mules can't reproduce. Whatever mule you'll get is the only mule you'll ever get. If you want to get another mule, you got to find another donkey and another horse, because it's just they're not similar enough to create offspring that can reproduce. So the problem with sexual reproduction is, again, if they're too different, either can't mate, won't mate, or the offspring are sterile. But Darwin acts like all organisms are all sets of Legos. Theoretically, if you just had if all animals were like Legos and you could just put them together indiscriminately, theoretically this could work, but that's not what we see. Limitless variation from natural selection, again, is theoretically possible if all animals could mate indiscriminately, but that is not what we observe. That is not what experimentally is supported. If we want a bigger gene pool, too bad, you've got your gene pool. And again, this is how his theory could be theoretically possible. Is if we had a bigger gene pool and all organisms could mate indiscriminately. Theoretically, if everything was Legos and you could put it together in all sorts of ways, that would work. But it's like, this thing's a Lego, this one's a Duplo. And then think about like a million different other types of Lego type things that don't fit with each other. They're never going to fit together, and that's a problem. That's not what we observe. So finally, I come in just under time. 4 main ideas I want you to take from this talk. Number 1, to understand that belief in evolution is not an all or nothing thing. I think I hope that I've shown you how there are ways that he did get it right. There are things we observe in natural selection that have predictive benefits. Learn how to spot buzzwords and ambiguous words. You will be so ahead of everyone else in your classes if you can do this. Science tells us nothing. Scientists tell us things. Remember, the same data can be interpreted by 2 different scientists. That depends on their opening philosophy. And anyone who tells you that there are no limits to the creative power of evolution is speaking beyond the evidence. And when we do science, we want it to be evidentially supported, not speculative. So go forth and discern.